second curve that is r is equal to a cos 5 theta is 5. Koई odd number is there, 5 is odd number, but each this loop will be between which angles? Let me that find out. Putting r equal to 0. So r equal to 0 implies that now it is symmetric to the initial line that we have described. So r equal to 0. That means a cos 5 theta equal to 0. And cos 5 theta equal to 0. This is nothing but cos pi by 2 plus minus pi by 2. 5 theta is equal to plus minus pi by 2, or theta is equal to plus minus pi by 10. So limits we will take minus pi by 10 to plus pi by 10. That is the area of one of the loops. So these loops are, let me take, these are the 5 loops here. Okay, there are 5 loops here. There are 5 loops. In between, 5 loops are there. We have not to, I'm just calculating this. Because we have 5 loops, any type of, but they are lying inside. So what is the angles between them? These two tangent lines, this theta equal to pi by 10 and this theta equal to minus pi by 10. So area of the circle is pi a square, because radius is a here. This is nothing but pi a square. R equal to a. We will take that as 1.2 a square. Pi a square 0.2 it will be. This is not r equal to 2a, but r equal to a here. That we will just calculate. Circle, area of the circle minus area of the 5 loops. First area of one loop, then 5 times of that. Area of the total loops we will calculate. Let me find out area of the 5 loops. For that, angle theta is pi by 2. So area of one loop. So area of one loop is equal to 1.2 limits. If I take twice of this, let me take minus pi by 2, minus pi by 10 to plus pi by 10 into r square into d theta. This is r square here. Okay. Or we can take it twice into 1.2, 0 to pi by 10. And this is here r square. R square is a square into cos square 5 theta. This is cos square 5 theta, into d theta. So what we will do, this is 2 to cancel out here. This is nothing but 0 to pi by 10 a square that we take outside. This is cos square 5 theta d theta. Putting here 5 theta is equal to phi, let me take. Therefore d theta is equal to, differentiating with respect to phi, we get 1.5 into d phi. Simple. The value of limits. What are the limits here? And the limits at theta is equal to pi by 10. This is theta pi by 10. So 5 pi by 10 being 1.2. So that means phi is equal to, let me write here limits. At theta is equal to pi by 10. Phi is equal to 5 theta. That means 5 into pi by 10. That means pi by 2. And at theta is equal to 0. Phi is also 0. Because theta, 5 theta, theta 0, 5 into 0, 0, phi 0. So limits are 0 to pi by 2. But here d phi upon phi. So what is the total value here then? It is nothing but, let me write here. This is a square upon phi. This 1.5 I have taken outside. A square upon phi. This is 0 to pi by 2. This is cos square phi d phi. So finally, what is the answer? This is a square upon phi. A square upon phi into cos square phi by reduction formula. This is 1.2 into pi by 2 using by reduction formula, or we can write by reduction formula. This we have converted. This cos square phi here. Okay, so this is 0 to pi by 2 limits. Within these limits, this is therefore pi a square upon 20. So one loop, area of one loop is equal to, therefore area of one loop is equal to pi into a square upon 20. 5 4 the 20. This is pi a square upon 20. This is area of one loop. There are 5 loops. Therefore, area of 5 loops. Area of 5 loops. 5 into this. This is equal to 5 into area of one loop. So that is 5 into pi a square upon 20. 5 4 the 20. This is pi a square upon 4. This is area of all the 5 loops. Come to the point now. Now area of the circle, if I have to find out, again area of the circle 0 to pi by 2 limits if I put. So area of the circle, here r is equal to a square only. Okay, so limits we have to put again 0 to pi by 2. 1.2 area of the circle. This we are calculated. Twice of area of 0 to pi by 2. This is 0 to twice into 1.2. I am taking total area of the circle. Limit 0 to pi by 2. This is r square into d theta. 2 cancel out total area. This whole area of the circle we are calculating. This is only 0 to pi by 2. R square is a square here, circle, into d theta. Nothing but a square common, theta integration 0 to pi by 2. I tell that it is nothing but pi a square upon 2, because radius is a by 2 here. So pi a square upon 2. So pi a square, so twice of that area we have taken. So pi a square upon 2 here. Sorry, this is area of the circle. So this is pi by 2 and a square. So pi a square upon 2. Therefore, total area for area in between the circle and the 5 loops. So area between the circle and the 5 loops. So that the area contained between the circle, this, and the curve, this, is equal to 3/4 of the area of the circle. Area of the 3/4 is coming out to be different one. It must be as 3 by 4. It is not coming. It must be 3 pi by pi a square upon 4. Then it is 3 pi a, 3 times. It is 3 times, or this question we have. Okay. So that the area contained between the circle r is equal to a and the curve r is equal to a cos 5 theta is equal to 3/4. That's a 3/4. Okay, it's 3/4 here. This is pi a square upon 2, but 3 times it must be pi a square upon 4. Is it coming pi a square upon 4? Area of the circle. Okay, if it is 1.2, so area of the circle is pi a square upon, but limit 0 to pi by 2. Why I make then it pi by 2? It means this is pi a square upon 4. It must be 3 times pi a square upon 4. Then it is 3 times, 3/4 times or something. The area contained between the circle r equal to a and curve this is equal to the 3/4 of that. So 3 times 3 upon 4 times. Now, okay, difference we have to find out. Sorry, first we have to find out the difference. I'm sorry. Now, what the point? This is the area of the circle. This is area of the 5 cardioids. So difference of them. So that the area contained between the circle and the curve is equal to the difference of them. Then that area will be 3/4 of this. Okay, got the point. The question says, let me just clarify this point. It says the difference of these two areas we have to find out. Area between the curve and the circle and the curve area. Let me first find out between the circle and the curve. First we have to find out that is pi a square upon 2, this is area of the circle, minus pi a square upon 4, this is area of the curve. This curve, 5 curves, 5 loops I mean. What is the area? 4. This is 2 times 2 pi a square minus pi a square. It must be the difference of these two. It means this is pi a square. Area of the circle is pi a square. Why pi a square upon 2 is coming? But twice we have to multiply that. Okay. It was pi a square, area of the circle, because radius is a there. So area of the circle is only pi a square. If it is pi a square, area of the circle, then it is 4 pi a square minus pi a square. That means 3 by 4 pi a square. Area of the circle is pi a square. So we can say that area of the circle, okay, is 3 by 4 times of the difference is 3 by 4 pi a square. Now, so that the area contained between the circle r equal to a and the curve this is equal to 3/4 of the area of the circle. Okay, area of the circle must be pi a square. This let me show that why pi a square area of the circle. Why? Because this area radius is a only. Radius of the circle is a. So this is pi a square upon pi a square, and that comes out to 3 pi a square. Therefore, this area of the circle and the contained area is this in between. This area is 3 by 4 of this area. So this is the solve. Okay, let me continue this later.